In this video, I will introduce a paper about how low body joint can contribute to the power generation during the power snatch. But before I talk about the paper, I would like to share a research question that I had for this paper. There is a concept in weightlifting called triple extension. That means the ankle, the knee, and the hip joints needed to be extended almost simultaneously during the second pull in weightlifting motion. In other words, the low body joint kinetics is likely to affect the power generation in weightlifting motion. By the way, do all the low body joints positively contribute to the power production during the power snatch? Also, is there any correlation among the low body joint? I did this study to answer this question. The title of this paper is Evaluating the Contribution of Lower Extremity Kinetics to Whole Body Power Output during the Power Snatch. This paper was published in Sports Biomechanics Journal. Let me define the power snatch first. This is the continuous motion of a power snatch. The barbell is lifted from the floor to receive it overhead with the knee and hip slightly flexed. And then the power snatch is one of the variations of the snatch for the weightlifters. And then the power snatch has also been primarily used for the training purpose of the snatch. The power is key determinant for the success of Olympic weightlifting. And then there are different ways of calculating power output during weightlifting. So here I'd like to introduce different approaches to power calculation. The first one is a barbell power. This barbell power can be calculated by multiplying barbell force by barbell velocity. Here, barbell force means barbell mass times barbell acceleration plus barbell weight. And then the second one is whole body power. This one can be calculated by multiplying ground reaction force by whole body velocity. Here, whole body velocity can be calculated from the ground reaction force based on the relationship between impulse and momentum. And the next one is also whole body power. This one can be calculated by multiplying whole body force by barbell velocity. Here, whole body force means is whole body mass times barbell acceleration plus whole body weight. And the last one is whole body power as well. This one can be calculated by multiplying ground reaction force by barbell velocity. It is believed that the low body joint kinetics is likely to contribute to power output during the power snatch, because main movement during the first pull of the power snatch is the deadlift that involves all low body joints simultaneously moving against the resistance. Also, there is a concept in weightlifting called triple extension. That means the ankle, knee, hip joints need to be extended simultaneously during the second pull of the power snatch. There were several of the previous snatch studies, and then the studies primarily analyzed the bar and joint kinematics. And there are two studies that analyze joint kinetics as well as joint kinematics, but these two studies did not investigate whether the low body kinetics could contribute to power output. And then these are examples of bar kinematics and joint kinematics and joint kinetics. There is also methodological limitation in the previous studies, such as simultaneous calculation of the whole body power and then low body net joint torque. For example, combined GRF. Here GRF means ground reaction force. Combined GRF was collected to compute whole body power during weightlifting motion using a single force plate with a lifter's feet on it. And whole body power was then calculated by the product of combined GRF and either barbell or whole body velocity. However, in order to properly measure low body net joint torque, ground reaction force needs to be independently collected from two force plates with each foot on each force plate. This methodological limitation can be resolved by collecting both combined GRF and independent GRFs from each force plate simultaneously. And therefore, the purpose of this study was to examine whether the low body net joint torque significantly correlated with the whole body power during the power snatch, and to evaluate the contribution of each low body net joint torque to whole body power if significant correlations existed. And method, participant, 10 skilled non-professional males volunteered to participate in this study. Then they had at least 3 years of power snatch experience. And for trial conditions, 1 item testing was performed 1 week prior to data collection. And 1 week later, they returned for actual data collection. And then 6% of 1 item was used as a testing load for this study. And then we used Vicon motion capture system, and then 2 force plate, and then a total of 59 markers were attached to the participant's body. And then we also used Quant3D XP motion analysis software to pull out the biomechanical variables. For biomechanical variables, the net joint torques of the low body were calculated using an inverse dynamics approach. And here hip, the knee, and ankle net joint torques. And then whole body power. Whole body power was also calculated by multiplying the combined vertical ground reaction force by whole body vertical center of mass velocity. To facilitate data analysis, the power snatch motion was subdivided into 4 phases. And then we used the ensemble average pattern of whole body vertical center of mass velocity. This is the center of mass velocity, vertical velocity. Now let's take a look at these 5 events first we used for obtaining these 4 phases. Okay, S represents start of the snatch, SP represents start of the plateau, EP represents end of plateau, okay, PV represents peak velocity, then TO represents toe off, and then IP phase, which means initial pull phase. Then PT phase means is a plateau phase, and then PG means power generation phase, and then BT means bar throw phase. For statistical analysis, Pearson correlation coefficients were obtained to observe the relationship between the low body net joint torque and whole body power. Also, multiple regression analysis was conducted to evaluate the contribution of the low body net joint torque to whole body power during the power snatch. And independent variables were hip, knee, and ankle net joint torques, and dependent variables was whole body power. Then we used SPSS, and the significant level was set at 0.05. Correlation result. If you take a look at this table here, okay, hip net joint torque showed a significant positive correlation with the whole body power, whereas knee net joint torque showed a significant negative correlation with the whole body power. And significant intercorrelation was also observed between hip and the knee net joint torque, which can indicate that hip net joint torque increased as the knee net joint decreased, and vice versa. And regression result, if you take a look at this table here, the hip net joint torque appeared to be a significant positive contributor to the whole body power. Before we discuss the results, I would like to talk a little bit more about power computation. In terms of power computations, different methods have been used in previous weightlifting studies. And the power computation method needs to be carefully selected based on the nature of the study because there's a significant difference in power output among the various methods. That's why. And the significant difference in power output between the whole body power and the barbell power was also observed in our studies. So here, the whole body power, black line represent whole body power, the yellow line represent the barbell power. The whole body power was calculated by multiplying, as I mentioned earlier, by multiplying combined GRF by whole body vertical velocity. And the barbell power was calculated by multiplying combined GRF by the barbell velocity. In our study, we used whole body power because we focused more on how the lower body joint can affect the whole body movement than on how they can affect the barbell movement in the power snatch. And the contribution of the lower body net joint torque to whole body power. The hip net joint torque appeared to be a significant contributor to the whole body power during the power snatch in this study. Therefore, it can be determined that the increase in extensor use would help individual to increase whole body power during the power snatch. And also, hip, the knee net joint torque, negative intercorrelation was also observed between the hip and the knee net joint torque. Okay? These negative intercorrelations are likely to be driven by the joint movement mechanism to compensate for the changed net joint torque of the adjacent joint. In conclusion, practically so what? So based on the findings of this study, it can be concluded that the training skills allowing weightlifters to utilize hip extensor muscle action would help to improve whole body power during the power snatch. And these are all references for this paper. Thank you for watching this video.